Well, many people think that barnacles are plants. Actually, in Swedish, the Swedish name for barnacle is havstulpan, and that means sea tulip. But they are crustaceans related to crabs, shrimps, lobsters, and so on. Well, both as larvae and adult, they feed on phytoplankton, and by doing this, they transfer nutrition, energy from lower levels to higher levels in the food chain. There is fierce competition for available hard surfaces in the sea, and barnacles are one of the quickest to find such surfaces. They can be on turtle shells, on lobsters, on boats, whales even, and they search for a place where other adult barnacles already are living, because that is obviously a good place to live. And since they cannot move as adults, they need to be very close to other barnacles to find a mating partner. And when they find this, they turn their head down, they glue themselves to the surface, they turn their feet up, and they start growing a calcareous skeleton.
The presence of tube worms, oysters and barnacles are the sign of a natural, healthy ecosystem. However, when these organisms attach themselves to ships, boats or structures, they are termed fouling. And fouling can be a tremendous problem to the efficient operation of these activities. To combat the problem, we use anti-fouling coatings. Traditionally, these contain biocides, and the biocides poison any organisms that come into contact with the surface. In the 1970s, we used the tributyl tin biocides as a means of controlling fouling, but unfortunately, they had deleterious effects on the environment. So this has left the shipping industry in a bit of a dilemma, because whilst there are some very good commercial coatings out there, none provide the same performance of the organotin paints. So now we have the need for research and development into alternative coatings that are totally environmentally acceptable and function to maintain the ship hull free of fouling and also in what we call a hydrodynamically smooth condition. Well, the shipping industry is huge. It's estimated that there are over 100,000 vessels, and they transport between 80 to 90% of the world trade by volume. It's also been estimated that in total they consume over 333 million tons of fuel, and that is in tonnage third only behind the USA and China in terms of total consumption. And so from a global perspective, it is seen that if we can improve the efficiency of shipping, then we'll go a long way to improving environmental problems such as greenhouse gas emissions, and also, obviously, any input from biocides that may be used in anti-fouling paints.
Fouling is something that definitely impacts us a lot, because what we do is we transport things, and to do that we do it through water. So the fouling is something that actually hinders us from doing that in an efficient way. So every time we get any sort of fouling on the hull, on the propeller, on the rudder, whatever it is, it will actually hinder us from doing an efficient job. What we've seen, especially lately, and what we're going to see more in the future, is that the cost of fuel or of energy in whatever form it's going to be is going to increase. I think that's going to affect us dramatically from now and going into the future.
There's been a lot of work during the last 5-10 years, work and discussions to control CO2 emissions because of the climate effect. So far, the shipping has not been so involved in those discussions, but this is now changing. And both the politicians and the public at large are setting some demands also on shipping, not only on land-based industry. I believe that the frictional resistance of ships is very important. So if we can control the fouling in a more effective way, at the same time using more environmentally friendly paints, we could have a dramatic reduce in CO2 emissions, maybe in the order of 10%.
The other big problem, of course, is with species that live in the fouling. So when we move a ship from Australia to Europe, for example, we can be bringing species with us that are not naturally living in Europe. And that's the second problem with fouling.
We are now at Tjärnö Marine Biological Station, and this station has a long tradition of performing environmental research. It was here that we made a discovery that the substance medetomidine could be used in antifouling paints. There are many demands on an antifouling substance. It has to be effective, environmentally safe, but also safe for users. It's not easy to find a substance that fulfills all the criteria. For us, it was obvious that we had to know as much as possible about the barnacle biology. It had to be possible to avoid barnacles on ship hulls by other means than killing them. It should be possible to take advantage of the barnacle biology to deter them instead. At first we believed that medetomidine blocked the cement secretion, but it was not the case. Instead it affected the behavior of the larvae. When a barnacle larva approaches a surface, it starts to explore it with its antenna to find the most optimum place for attachment. When that is found, the barnacle larva glues itself towards the surface, and the metamorphosis begins towards an adult barnacle. If medetomidine is present, the larva is forced to swim away. The effect is only seen in close contact with the ship hull, and the effect on the barnacle larva is temporary and reversible and does not cause any permanent damages to the barnacle larvae or other marine organisms. And the barnacles can complete their life cycle elsewhere in their natural habitat.